Hello class, today we're going to go ahead and look at section 6.1, which is properties of exponents, and we're also going to take a look at scientific notation. So first, for properties of exponents, to simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. Also, you should see each variable written only one time. Okay, so let's just talk about what are the rules. Okay, so product of powers. Okay, so when you're multiplying monomials, so mono means one. Okay, you're going to add their exponents. So in that fill in the blank, where there's that blank box on your note sheet, write out that that's when you add the exponents. For product of power, as you add exponents. So for example, I have x squared times x to the third times x to the fourth. So what I need to do is these are monomials. There's one of each. Okay, I'm going to add their exponents. I have 2 plus 3 is 5. Okay, so this gives me 5. 5 plus 4 is 9. So it's really x to the 9th. So here it is simplified all the way. There's only one x, and there is no negative exponents. Another example, I have m times m to the second. Well, this is really m to the first. So if I add 1 plus 2, it's really m to the 1 plus 2 gives me m to the third. So that's product of powers. Now let's go ahead and look at the power of powers property. Okay, with powers of powers property, okay, this is when taking a power to another power, you are going to multiply the exponents. Okay. So for example, I have y squared to the fourth. So what I need to do is multiply that. So it's y is 2 times 4, so y to the 8th. And my next one, it's to the third power, all of it. So the way I would do this is every single part gets multiplied to the third. Okay, so every exponent. So this is really 4 to the 1. Okay, so 1 times 3 is 3, so it's 4 to the third. Then it's x to the second times 3, so it's x to the 6th. And then this is really y to the first, so 1 times 3 is 3. So y to the third. And then there's only one last thing that I would probably, you should simplify is 4 to the third. If you put that in your calculator, you'll get that is 64, x to the 6th, y to the third. Okay, so it's power of powers. So if you have a power or an exponent to another power. The next one is quotient of powers property. So that's when you are dividing. Okay, when you are dividing monomials, what you want to do is you want to subtract, okay, subtract their exponents. So for this example, I have m to the 5th over m to the 11th. What I would say is, well, which one is bigger, and you want to subtract the smaller from the bigger one. So this is smaller, so I would actually take 11 minus 5. So it's 1 over m, 11 minus 5. So I get 1 over m to the 6th. Okay. My next example, once again, I look at where the bigger one is. 7 is bigger, so I'm going to subtract 3 from it. So it's a to the 7 minus 3, or a to the 4th. And there it is, simplified. So that is quotient of powers. Now I have negative exponents. Okay. You cannot leave any negative exponents in a final answer. Okay. So what you need to do to fix a negative exponent, move it to the inverse side of the fraction and make the exponent positive. Okay. So what this really means is if I look at my example, I can write anything over 1. Okay. Move it to the inverse side, so the opposite side. So I would take this and move it down here. Okay. And now I make the exponent positive. So this is really 3a to the 5th. And that would be my solution. The next one, I go ahead and look at it. It is a fraction. Now what I'm going to do, this is negative, so move it up, and make the exponent positive. So this one equals 2x to the third. And the last rule that we need to talk about is a zero exponent. Whenever there is a zero exponent, okay, anything to the 0 power is always 1. Okay. So notice all of this is being taken to the 0 power, so it is 1. Okay. Now if I look at my second example, not everything is being taken to the 0 power, only x to the 0 power. So this is 1. So I have 5 times 1, which is 5. One thing to notice, if I had 5x parentheses to the 0, then all of this would be 1. So that's the difference there. Okay. So now we're going to go ahead and do some practice simplifying. Okay. So just remember you can't have negatives, negative fractions, and you have to combine everything. So the first thing I would do is look at your numeric values. I have 3 and negative 4, and they are being multiplied. So 3 times negative 4 is negative 12. Now I look at my x's. X squared times x squared, well, when I multiply, I add exponents, so it's x to the 4th. And now I have y squared times y to the 4th. When I multiply, once again, I add. So 2 plus 4 is 6. Now I look, do I have any negative exponents? I do not, so I am all the way done. Okay, moving on to example 2. Once again, right away, I would notice that we are multiplying everything here. So I would multiply all the common bases. The common base for this one, anybody who has an a. So I have a to the negative 3rd times a to the 2nd. Well, that's going to give me a to the negative 1. Negative 3 plus 2 is negative 1. Now I look at b. There is only b to the 4th. And then lastly, I only have c left. So it's c to the negative 1. Okay, I've done the multiplication, but now I have to look, do I have any negative exponents? Yes, I do. So I would go ahead, if it's negative, I'm going to do the inverse or move it to the other part of the fraction. So remember, all of this is really over 1. So I would take and move a to the negative 1 to the denominator. So I would have a to the 1st. And my c is also negative, so I would move that down. So it's c to the 1st. And then I would still have b to the 4th in my numerator. And we typically do not write that when it is to the 1st power. So the simplified all the way would be b to the 4th over a times c. Example 3. I see that there is division, so I'm going to use the quotient rule. I want to bring the smaller number to the bigger number. So I'm going to move this. Okay, so I'm going to bring that to the denominator. Kind of if I use my inverse property, okay, I would have 1 over, well, I'd have p to the 8th, and now I do the opposite. It'd be p to the negative 3rd. And then 8 times p to the 8 times p to the negative 3rd, I would add those exponents. So it gives me 1 over p to the 5th. And 4, once again, we're going to go ahead. We are dividing. So same idea here. Take care of those numbers. 15 divided by negative 3 is negative 5. So I'm just going to draw myself a line to show that there's a numerator and denominator. And now I would say, well, I'm going to bring this up here. So it's really 5 minus 2. So I have c to the 3rd. And now I also would notice that there was another c. So I'm going to leave that c to the 7th here. And then there's a d to the 3rd. Okay. So now I see that I still have 2 c's left. Okay. So what I would do is now I'm going to say, well, bring this guy to the denominator. So I have negative 5 d to the 3rd, c to the 4th. 7 minus 3 is 4. Okay. That's one way to look at it. Let's go ahead and look at it another way. So I'm just going to rewrite it. The first time I did it, I didn't notice there was 2 c's in the denominator, so this might happen to you. So another way you can solve it is I would first probably combine those after I notice that. So same thing, 15 divided by negative 3 is negative 5. And then I would have c to the 5th, d to the 3rd, all over. C squared times c to the 7th gives me c to the 9th. And now, this is the smaller exponent, so I'm going to move it down here. So I would really have 9, c to the 9 minus 5. So I get negative 5 d to the 3rd over c to the 9 minus 5 gives me 4. So I still get the same answer. So there's more than one way to do these types of problems. Okay. If you have any questions so far on any of the examples we've done, please pause the video, write down your question, make sure to ask me in class so that we can get any questions you have answered. Example 5. Okay. This is our power of powers property. So I'm going to take everything to the 5th power. Okay. So I'm just going to rewrite. It's really negative 2 to the 5th. P, well, 3 times 5 is 15. And R, 2 times 5 is 10. If you, on your calculator, use parentheses, because it's a negative, parenthesis negative 2, parenthesis to the 5th, you will get that this is negative 32, P to the 15th, R to the 10th. And that is simplified all the way. I do not have any negative exponents. 6. Once again, it's a power of a power. So each part gets that multiplied by negative 3. So I would have A to the negative 3 over 4 to the negative 3. Now remember, whenever you have a negative exponent, you move it to the inverse of the fraction. Okay, so this one, I'm going to move so that I would have A in the denominator. So it's A to the 3rd, and I'm going to move my denominator up so I would have 4 to the 3rd. And the only last thing I would do is figure out, well, what is 4 to the 3rd? It is 64 over A to the 3rd. You could just type 4 to the 3rd in on your calculator. Okay. So this is kind of the end of our properties of exponents. So if you have any questions on those, go ahead and write them down. Now would be a good time to actually pause the video if you wanted to take a break. We're going to move on to scientific notation next. Okay. So scientific notation. The form that we usually write numbers in is what we call standard form. Okay. A number is in scientific notation when it is in the form A times 10 to the nth. Okay. So it doesn't look very clear, but it's 10 to the nth power. Okay, where 1 is less than or equal to A is less than 10. So really, A can be the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's it. Okay. And n has to be an integer. So integer means that it is, there's no decimal part added onto it. Okay, so there's no decimal or fraction part. So example 7. The density of an object in grams per milliliter is found by dividing the mass of the substance by the volume. Okay, so they wrote that out right here. Density is equal to mass divided by volume. A sample of platinum has a mass of 8.4 times 10 to the negative second kilogram and a volume of 4 times 10 to the negative 6 cubic meter. Use this information to calculate the density of platinum. Okay. Here's a little off to the side, a little example of the density, so if you wanted to look that over. But we're going to go ahead and calculate this. The density, I'm going to use D, is equal to the mass. The mass was 8.4 times 10 to the negative second over the volume, which is 4 times 10 to the negative 6. Okay. And what we would need to do is 8.4 divided by 4. And if you do that, okay, 8.4 divided by 4, it gives you 2.1 times, now we use our rules of exponents again. If I have 10 to the negative second divided by 10 to the negative 6, I would move this negative 6 up here. So I would have negative 2 negative 2 minus a negative 6, so it gives us negative 2 plus 6, which gives us 10 to the 4th. And this would be in kilograms per meters cubed. Example 8. After the Sun, the next closest star to Earth is Alpha Centauri, which is about 4 times 10 to the 6 meters away. How long does it take the light from Alpha Centauri C to reach Earth? Okay. Well, in this case, we're going to be using the equation distance equals rate times time. And they also tell us that light travels at a speed of 3.00 times 10 to the 8th meters per second. Speed is just another word for the rate. Okay, if I travel at 60 miles per hour, that's the rate. It's also the speed. Okay, so we want to know how long does it take? Well, my equation is distance equals rate times time. And if I want to know how long it takes, I'm trying to figure out what t is. Okay, so in order to figure out what t is, I would divide both sides by r. So distance over rate is equal to time. So we're going to go ahead and plug in what is the distance and what is the rate to figure out time. So our distance, it's 4 times 10 to the 16th meters away, all over the rate, 3.00 times 10 to the 8th. Okay. Same idea as before. I would take 4 divided by 3.00, okay, which gives me 1.3 repeating, times 10, 16 minus 8, because if I go ahead and move this up here, it's going to be 10 to the 8th. So my time, okay, and what is time labeled in? Time they're talking about in seconds. And one last problem, very similar. The average distance from Earth to Moon is about 3.84 times 10 to the 8th meters. How long would it take a radio signal traveling at the speed of light to cover that distance? Well, once again, it wants to know how long. So if you remember from the problem before, we had that time is equal to the distance divided by the rate. Well, our distance in this case is 3.84 times 10 to the 8th over our speed of light, that's our rate, 3 times 10 to the 8th. So if I go ahead and take 3.84 divided by 3, I get 1.28 times 10 to the, well, if I bring this up here, it'd be 10 to the 8th minus 8, so 10 to the 0. And we just got saying that anything to the 0 power is 1, so it's just 1.28, and this is time again, so seconds. Okay, so that will be it for the notes video today. So if you have any questions, be sure to write them on your paper, come and ask me in class. Otherwise, the next thing that you're going to be working on is the properties of exponents and scientific notation worksheet. Have a good day.